Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 5 we will continue. In lecture 45 we will continue with special waste management, and this is part 2 of the lecture. So here we will discuss about extended producer responsibility. Extended producer responsibility, particularly for brand owners. There is EPR responsibilities have been for producers as well as importers, but we will discuss only about brand owners in this particular lecture. Then EPR waste collection system, biomedical waste. Then we will talk about biomedical waste management rules 2016. Then we will discuss about slaughterhouse waste management, e-waste management, waste tire management, and lead battery waste management as well. So the guidelines of extended producer responsibility for plastic packaging is, you can say, it complements the plastic waste management rules, because as we have said that a lot of change has to be done at the production side. Now, we have to make sure that the producers play a big role in this particular process. So, these rules, guidelines apply for producers of plastic waste, importers of plastic waste, as well as brand owners who use this plastic waste to create products finally to sell it to the consumers. Now, so that means this extended producer responsibility is applicable not only to post-consumer plastic packaging, which in the last lecture we have discussed mostly about post-consumer plastic waste that is being produced, but also the plastic waste which is produced at the pre-consumer stage as well. So that means some amount of plastic is utilized by the producers themselves and all, and that there a lot of waste is generated at that part. So it's before it reaches the consumer. So that also is being considered over here. Now EPRs more or less covers reuse of plastic, recycling of plastic, use of recycled plastic content in new products, end of life disposal, finally how the plastic is disposed. So all these different aspects are covered in extended producer responsibility guidelines. Now here in EPR guidelines, 4 categories of plastics are being mentioned. Category 1, 4 categories. Category 1 is rigid plastic packaging. Category 2 is flexible plastic packaging of single layer or multi-layer, but all plastic layers. Plastic sheets and covers made of plastic sheets, carry bags, plastic sachet or pouches. Category 3 is multi-layer plastic packaging, where at least one layer of plastic and one layer of alternative material is there. So multi-layer could be all layers of plastic, that has to be dealt differently, whereas other multi-layered is something where like Tetra Pak and all, which uses multiple, not only plastic but other materials. Category 4, the final one, is plastic sheet or similar used for packaging as well as carry bags made of combustible plastic. So this is what is separate from the other kinds of plastic. Now when we talk about this responsibility, it applies to importers, producers as well as brand owners. Now what they are supposed to do? So the government has set an extended EPR responsibility target. So that means how much percentage of waste has to be considered while we do this, EPR activities. Then how much obligation for reuse, how much of that percentage is actually could be reused, what percentage of that could be recycled. So one is reusing of, again, one is recycling that particular, percentage of waste that we are talking about in the EPR target. And finally, how much percentage of that will go for end of life disposal, or what will be disposed finally. And finally, obligation for use of recycled plastic content. The final thing is, we can say that so much amount would be recycled, fine. But what amount will be recycled in your own product? So that means obligation of use of recycled plastic content in producing your own product, that also is considered. So eligible, when we discuss this in detail, and we are not discussing it for the importers or the producers, but we are discussing it that you can look at the guidelines which is available, and you can and what we would discuss is from about the CPR guidelines which are for the brand owners. What the brand owner should do, what are the guidelines for them. Similar guidelines are there for the importers as well as the producers as well. Now, first of all, what percentage of material or plastic that we will consider for this category of plastic producers or users. So, the eligible quantity in metric tons, in million tons is Q3, and this is considered for the last 2 financial years. This has got 2 components. The first component is average weight of virgin plastic packaging material for different categories, of course, purchased and introduced in the market, which is category A, and average quantity of pre-consumer plastic packaging that you are usually employing yourself or using yourself. So, these 2 categories are together makes up the quantity of plastic which a brand owner is actually handling or producing or using, you can say. So, out of that, by the year 2021, by the year 2022, around 25% of that comes under the EPR responsibility. Then by year 2023, it should be 70%, and by 24, it should be 100%. That means 100% of the overall use plastic that is being utilized should come under this EPR responsibility. Now, what kind of EPR responsibility we are talking about? One could be in the package design itself. That means, how do I design the packaging of material so that we can go for this kind of we can follow the EPR responsibilities, because EPR responsibility is all about recycling, reuse and so on, right? So, if the material design is such that it facilitates reuse, facilitates recycling, then it's better. So, package design has to be done in such a way so that it promotes reuse. Then it should be amenable for recycling. So, we cannot design packages which uses material which are not suitable for recycling. So, it should be suitable for reuse in some case. The packaging can be used for something else, or it could be recycled. Finally, the recycled plastic content, what percentage of recycled content is there in that package itself, that is also important. And finally, package design should be such so that it doesn't harm the environment. So, these are the different things that has to be considered by the brand owners when they design packages for the products that they produce, and eventually it goes to the consumers. So, because this is what actually, this package design is what actually that generates the plastic in the first place. Now, coming to the first set of obligations, which is obligations for reuse. How much amount of plastic you can reuse yourself, right? So, that means the targets which are set are for 2 categories of plastic. One is category 1 plastic, but which is equal or more than 0.9 liter or kg, but less than 4.9 liters or kg of plastic. So, this is around for the year 25-26, this is considered as 10% of this Q3 value. Then for 27, it is 15%, 28, it is around 20%, and finally 25% for the year 29 onwards. So, this is the target for now. So, that means 25% of this Q value, this Q3 value, or this total value of plastic that they are designing, that should be, we would be able to reuse that for some purposes. Similarly, for category 1 rigid, but more than which are equal or more than 0.9 liter or kg, but less than 0.4 liters or kg. So, in that case, the values are a little bit different. It should be 70%, 75%, 80%, and finally 85%. So, these are the 2 categories of waste, 2 categories of plastic. Then coming to obligation for recycling, that means after reuse we should also consider recycling, which is minimum level of recycling, leaving aside the component which goes for disposal, that is end of life disposal, that means we cannot recycle that, or plastic packaging waste, and this is also given as a percentage of the extended producer responsibility target. So this should complement the amount which is reused. So that means reused plus recycling together should make up the amount which is there, which is not going to be disposed of. So disposed of plus recycled plus reused together makes up the entire amount of plastic waste. So category 1, again the targets are given for category 1, category 2, category 3 and category 4 plastics, and you can see for different years separate targets have been there. So coming to the final one, for 2027 to 28, for category 1 the recycling target is 80%, for category 2 it is 60%, same for category 3, and finally for category 4 it is 80%. Now once the recycling is over, the next of course is the non-recyclable end of life disposal of plastic, which includes the non-recyclable plastics, and then remaining amount which cannot be recycled, which cannot be reused, that should go for road construction and waste to energy or waste to oil processes, which we discussed in the last lecture. Now the other set of guidelines given by the government is mandatory use of plastic in packaging manufactured in percentage, that is obligation for use of recycled plastic content in my own packaging content. For again that is given for category 1 to 3, because the final one, that is biodegradable plastic, cannot be recycled in that sense, right? So of course for category 1 to 3 these rules are given. Here again if I go for the final one, that is for the year 27-28, the category 1, the 60% of material has to be mandatorily reused in my own product, 20% for category 2 and 10% for category 3. Now along with these basic targets in regards to production, the extended producer responsibility also extends to the plastic waste collection system. That means there is responsibility from the producers or importers or the brand owners to also collect back the plastic, that we have learnt earlier as well. So development of collection and segregation infrastructure for different categories of plastics, so that has to be taken up. So as we know that plastic has to be subcategorized, so a lot of effort has to be put in. So producers or brand owners, they can actually set up these plastic waste collection points, and they can create a network of that, so that and along with material recovery facilities where this kind of processing can be done. So they can also participate in the collection process from this particular collection points, and offer the collection of plastic from ULBs, Gram Panchayats. So they may ask the ULBs and Panchayats that they are interested to do this kind of processing and so on. So they may be interested to this kind of work. So they can take over the collection, segregation, sorting process for plastic, and ensuring recycling or permitted end use of plastic. So there is also need for there is also guidelines also state about the need for a centralized online portal, so that we can track how much is being how the producers, this importers or the brand owners are actually doing recycling or reusing plastic and so on. And the monitoring has to be done by the State Pollution Control Board or Pollution Control Committees, and there has to be a committee for extended producer responsibility, which revises these guidelines after certain times. So that is all about extended producer responsibility, and as you can understand, without extended producer responsibility, we cannot reduce the total quantity of waste that is generated for plastic, of course. Then coming to the other kinds of special waste, we will talk about biomedical waste. So again, biomedical waste is that which is generated during diagnosis, treatment or immunization of human beings or animals, or research activities pertaining thereto, or in the production or testing of biological or in health camps, including categories mentioned in Schedule 1. So the biological waste management rules in Schedule 1, it gives a detailed list of what categories of waste are there and what falls under those categories. Usually there are 4 categories, and they are also coded in different colors. As you can see over here, yellow is infectious waste, which contains anatomical waste, chemical waste, soiled waste, chemotherapy waste, discarded linen, medicines and laboratory waste. Then infected plastics, plastic material which gets infected with this kind of material, this is contaminated plastic waste. So this definitely we cannot reuse, but here because it's plastic, after proper treatment we can reuse this. Then glass waste and metallic implants, it goes in the blue container. And finally metal sharps, which includes all those materials which has got like injection syringes and all these things, which are also dealt with separately. Now, in addition to this biomedical waste, biomedical facility itself generates other types of waste as well. So, for example, kitchen waste, store waste, residential waste collected from residential facilities, gardens, and so on. So, usually we assume that out of all the waste that is generated from this kind of facilities, only 25 to 30% is biomedical waste, and that has to be handled separately and with proper care. Whereas the rest of the waste can be considered as part of the normal municipal waste streams and can be handled accordingly. Now, in regards to the biomedical waste management rules, I will point to certain highlights of this particular rules. One is of course the term occupier, this is being utilized, which is basically an institution generating biomedical waste and is responsible for ensuring its handling, and the handling has to be done so that the human health and environment is not affected. So the responsibility goes to the occupier of any kind of institution which generates this kind of waste, right? So that means this is not the responsibility of the ULB directly. So whatever other waste is generated, it is the responsibility of the ULB to collect, segregate and process that waste, but the biomedical waste itself is not the responsibility of the ULB. So this has to be there, this has to be managed by a separate system. So there has to be proper categorization of biomedical waste, like we learnt in the last slide, what are the different categories, on-site and off-site storage rules for them, transport mechanisms, treatment and disposal mechanisms for this kind of waste. Again, this treatment mechanism is different. Lot of incinerators, autoclaves, all these different materials processes are utilized. But again, these are not directly the responsibility of the ULB. Now, what is suggested is the use of a barcode system for bags and containers. Now, as you know, that barcode system helps us in tracking the movement of the waste from one area to another. So if we can, in case of some contamination or in case of some discrepancy, this barcode system can help us in tracking where the problem is, and accordingly we can address that particular problem. Now, the incinerators that are also proposed, there are a lot of stringent standards that are developed for the incineration process as well as the incinerators that are used to handle this biomedical waste. So, because these are special kinds of waste, they need to be treated in separate ways. So there are standards for retention time, particularly in the secondary chamber of incinerators. We have learnt earlier about incineration process. So in the secondary chamber, the retention time is controlled so that dioxins and furans are not produced. So this is one big toxic element which has to be reduced. So these are some of the aspects that has to be looked into. In addition, there are different schedules in this particular waste. Schedule 3 talks about local authorities such as Gram Panchayats, municipalities or corporations. This is the role of ULBs to provide or allocate suitable land for setting up common biomedical waste treatment facility in their respective jurisdiction as per CPCB guidelines. So their job is to provide the area where this kind of common biomedical waste treatment facility can be generated or could be set up, so that this kind of treatment can be done. But the collection and all this process is actually managed by the generator themselves. Then Schedule 1 Part 2, which is another important thing, then in certain cases biomedical waste is generated in the household. For example, some patients are there inside house, or some deliveries happen inside house. So some waste is generated within the household. So in that case, the responsibility of the generator or the household is to segregate waste and then hand it over in separate bags or containers to the municipal waste collectors. So that is where the ULB is getting involved. Now the municipal waste collector, or the ULB you can say in this case, they can have a tie-up with a common biomedical waste treatment and disposal facility like over here, and these people can come with their own vehicle and they can pick up the waste from either the material recovery facility or even directly from the household, and then they can take it waste for for proper treatment in that facility. So usually the biomedical waste treatment facility, you have a collection system or a group of vehicles which will go and visit different facility for waste generator or biomedical waste generator and pick up the waste from those particular points. But this is for different hospitals and all. But in case there are some waste is generated in the household level and there is a request to collect that, they can also come and do that. But usually this is handled by the ULB. They can keep it separately in the material recovery facility, and from there this agency can come, whichever these guys are tied up with, and they can come and they can collect the waste from there itself. Now next we will talk about slaughterhouse waste. This is another waste that is generated in urban areas, but we have to be careful about its disposal. It's a special waste. So usually we dispose this waste in landfills, and the other is we can also process it in compost plants. Not all kinds of slaughterhouse waste could be processed in compost plants, but these are the two options for final processing and disposal. So either we process it in compost plants or we can finally dispose it in landfills. Now before we even go into disposal, we need to scientifically process and of course dispose the slaughterhouse waste. Now we have to first reduce the quantity of slaughterhouse waste that is being generated. So first we have to recover as much amount of waste that we can recover from that particular waste and make it into usable materials within the slaughterhouse itself. And finally, safe disposal of residual pathogenic biological waste has to be taken up. So first is recovery and then finally disposal of the material, because this is a contaminated material. Now modern slaughterhouse activities not only includes just slaughtering, it includes slaughtering, dressing, cutting, inspection of meats of different sizes and for different purposes, refrigeration, maybe storing, curing, and also manufacturing of byproducts. This is very, very important. That means not only the meat is being produced, but we can process the remaining material and we can create a lot of byproducts. That overall reduces the total quantity of waste that is being generated. Now, there could be large slaughterhouses which processes more than 70 tons of live weight killed per day, or medium ones 15 to 70, and small ones which can process less than 15 tons of live weight killed per day. So that is how we can designate them. And the waste generated from slaughterhouse are of three kinds: solid waste, liquid waste, and gas of course. Now solid waste are the manure, like for example you have a chicken, poultry, so of course you feed them, and then lot of this waste material from the excreta of chickens and all that is being produced. So that is, we can use it as manure and so on. So manure, intestinal contents, hair, horns, hooves, gallbladders, all the different components, as well as different cartons and plastics that are utilized by this facility. Then liquid waste is urine, blood, wastewater. Wastewater is utilized in the different slaughterhouse processes. But this blood is because of this culling, blood is there, and urine and other waste materials also is there because these are animals. This effluent, this all gets mixed together. If we don't process it, this effluent is very toxic to be received directly by water bodies. So we need to have some amount of effluent treatment for this kind of waste. And finally, gases, odors, bad odors can be generated, other emissions can also happen. But usually we are more concerned about treating the liquid waste and the solid waste to reduce it before it goes into the landfill site. Now, the ULB can handle this waste. It can go for deep burial of the carcasses. And animals also, there are a lot of carcasses from accidents, like animals which dies in accidents and so on. So they should be buried deep so that they are not dug up by other animals for eating or something, other dogs and all can dig up that waste and they can eat from that. So to prevent that, we can go for deep burial. And slaughterhouse waste processing or disposal facility also could be considered. Now, one of the primary material is like as you can see over here, this is a biogas system which is generated from slaughterhouse waste. Now, some of the byproducts which we get from slaughterhouse waste, such as a byproduct, usually small facilities will not have any byproducts. They don't have that kind of setup, but large facilities, we can have other processes where byproducts are generated. So, where that means these byproducts are produced via additional processing. So, these processes are known, some of these are rendering, paunch and viscera handling. The other is blood processing. The other is hide and hair processing. So, the hide, the skin and this hair is being processed for production of leather and other materials. That initial processing is done, and then they could be sent to those tanneries and so on. Blood can be processed for some uses and all. Rendering, paunch, viscera handling, these are processed, means further processing the remaining matter after taking out the meat, so that we boil those. Rendering is like we can boil that material, and we can recover the fats, bones, and we can generate some sort of byproducts. So, the fat is used in industrial purposes, soap and grease production and so on, whereas meat, bone and all this, the remaining ones can be used to generate stock feed and also for fertilizer production. Stock feed is the material that is used to feed the animals themselves, right, and then also for fertilizer production. So, the different kinds of utilization of slaughterhouse waste you can see in this particular table. This is from again CPHEO guidelines. So, type 1 is like mostly vegetable matter, rumen, stomach and intestinal contents, dung, agricultural residues. So, as you can understand, again there are different categories, small, medium, large, different kinds of slaughterhouse categories. Now, as you can understand, this is suitable for composting. So, we can either go for biomethanation or composting, right, in-vessel composting, in-vessel composting. So, same is there, and if it's a small plant, then what happens, we can do one common biomethanation or centralized facility where all this could be collected from different plants, and then we can process this kind of waste. The type 2 waste is animal matter such as inedible offal, tissues, meat trimmings, waste and condemned meat, bones, so on. So, either we can go for rendering or we can go for this condensate unit, where we can actually after the boiling happens in rendering, we can generate this, we can separate the fat, we can have this, we can create feedstock and all, and then the rest of the matter is condensated, and then the effluent is generated which has to be treated. So, this can be also done for large and medium plants. For small plants and all, we cannot have such kind of facilities, because this can only be there in only large plants, because these are additional processing that requires a lot of space, lot of other technologies. So, in smaller plants, the contents that come out of this kind of facilities, small slaughterhouses, we can take them for deep burial provided by the municipality. Then coming to e-waste, these are the other kind of special waste. As you know that in India, the quantity of e-waste is growing very fast, and because we are growing, we are using more amount of electronics and electrical material. So, the rate is something around 10% per annum, and to certain estimates that are there, in 2012 estimate, it was around 0.8 million tons of waste, which is, this estimate was done by a Central Pollution Control Board in India. Now, big problems with e-waste is people are not aware, neither are the generators or ULBs are aware of how to deal with this kind of waste. So, there is a lot of capacity building that is required in this particular domain. Then the total, the capacity to deal with this kind of waste, there may be one or two recyclers which can deal with this waste, but we require more. And also the processes are informal, they are dirty. So, as you can see in this particular images, even though this is not from India, but still this is informal. So, there is no standard way to do this kind of recycling. So, this has to be looked into. E-waste is segregated from the municipal waste stream and sent to authorized dismantlers or recyclers, but we require more of them. And usually extended producer responsibility is a big way to handle this kind of waste, because the companies which produce that particular waste is the best people to actually deal with this kind of waste. So how to manage the end of life of this particular product is best dealt through extended producer responsibility. Now, there are two categories of waste, category 1 and category 2. The category 1 is IT and telecommunication equipment waste, whereas category 2 is consumer electronics and electricals that are utilized in houses. And as you can see, television sets, then LCD, LCDs and other kinds of television sets, refrigerators, washing machines, air conditioners. And so this kind of material is handled by this category, whereas centralized data computers, then personal computing laptops, then notepads, then printers, cartridges, all these telex, telephones, cordless telephones, all these things could be handled under category 1 waste, and they can have separate recyclers, and this can go for other recyclers. Overall, there are a lot of hazardous and non-hazardous material present in this kind of e-waste. And rough estimates are there are around 50% is ferrous metals, 21% is plastic, and these are mostly not recyclable kind of plastic. So if you melt them, that they will lead to a lot of emissions and all. Then non-ferrous metals such as copper, aluminum, silver, gold, platinum, which comes to around 13%, and other components such as glass, etc., are around 16%. Then coming to waste tires. So this is a big challenge for ULBs because of the shape of this particular tire, of this particular material. Like you can see that if you want to dispose that, you have to shred it and then make it into smaller pieces and then put it in the landfill site, because otherwise it will stick out of the cell, that landfill cell where you will put this. The other thing is this kind of waste is also difficult because the transport process, it's difficult to carry and so on. So because of the shape and size of the tires, it's difficult to handle. It's also the weight is also there. It's made of tire is made of complex natural and synthetic rubber compounds which have got high calorific value and also other materials. So these are the primary constituents of a tire, and what you will see is because these are of high calorific value, when these are stored, then suddenly there is some spontaneous combustion also happens. It's easy to catch fire, and this fire is difficult to bring down. These tire fires are very difficult to be handled by fire services. Then usually you will find them in urban areas. These are illegally, taking up areas of the footpath by some agencies which actually handle this kind of waste, or like tire shops and all these things where this kind of tire change happens and all, and sometimes it is dumped in some plots and all. Then because the tire has got some inner area as well, this can be breeding grounds of disease vectors. A lot of mosquitoes are breeding inside tires, in the water that is that gets captured in the tires. Within that water, a lot of water, and this is the cause of malaria and dengue in India. Lot of insects and other animals can also breed in this particular spaces. So this creates a lot of problems in urban areas. So there are different uses for used tires, and ULBs can facilitate that. For example, retrading of tires. That means over here you can see the tire is being retraded. That means the tire is made of this kind of natural and synthetic rubbers. So that means they gradually wear off after time. So we can put an additional layer of rubber at the top, so that this process is known as retrading, so that we can reuse this tire again. Retaining walls for hill roads, so we can cut these tires, make it into large pieces, and they can help in retaining the walls or the sides in case of hilly areas, the roads and the profile, the slope we can retain. They can act as retaining walls for this particular hilly roads. Then erosion controls along drainage channels, so we can lay them around drainage channels so that they reduce erosion. They can act as coastal barriers for the waves. They can act as crash barriers, like over here. They are used as crash barriers. They are used in landfill construction because they have certain weights. They can be put on the liner materials to keep them down. After that, we will put on waste above that. Then the tires could be cut into smaller pieces. They are used for repair of shoes, for making shoe soles, gaskets, conveyor belts. And it could be also utilized in automobile floor mats, wheels for handcarts. So these are reuse of the tires. So these are the different kinds of reuse which could be facilitated by the ULB as well. Now we can, if we cannot reuse, then we can process some of this also. We can the processing is energy intensive and may result in some hazardous products. Usually when we do the processing, a lot of dust and buffing is produced, which is carcinogenic. The tires have got steel wires which needs to be separated, and then once the steel wires are separated, then we can shred the tires into smaller pieces. Now from scrap tires, this is what we can generate. Like for example, we can generate crumb rubber, we can generate steel, we can generate some amount of fibers and scrap materials. So you can see for track tires, the rubber part is 70%, whereas for car other equipment tires, these are around 78%, steel around 27% and in truck tires and 15% in car tires and other tires, and fiber and scraps are 3%, 7% and 15%. So these are the materials which can be recovered, which could be reused for or recycled for other purposes. This crumb rubber or some amount of, once we shred the tire, we can also use it for co-processing or generating energy in or as fuel. We can use it as fuel in cement plants, or so in that way we can also utilize this particular waste. Now there are no guidelines from the Government of India, but there are draft guidelines for regulation of tire retreading, tire pyrolysis, and prohibition on burning of tires has been brought up by Maharashtra, Government of Maharashtra in the year 2014. So they have suggested following life cycle approach for recycling for tires, and also they have suggested tire retreading, location of pyrolysis units where we can burn this tire, pollution control measures, safety arrangements and environmental compliances for this kind of facilities. The final kind of special waste that we will discuss is about lead battery waste. So usually this battery is a hazardous waste and we have to deal it following the battery management and handling rules of 2001, and this is again not directly undertaken by the ULBs. Nothing of processing of this kind of waste is not directly done by the ULBs, but used batteries are collected. Once if it is collected in the municipal waste stream, then it has to be segregated and then sent to the proper recycling or processing facility. But other than that, used batteries are collected when new batteries are sold. So that's one way you can say extended producer responsibility is there for battery waste management. Safe transportation to collection centers or recyclers by whichever company or whichever retailer collects this kind of batteries, they have to follow this. So there has to be some setup of transportation system and collection centers and so on. So again, this collection centers could be done by the company or the brands themselves which produce this kind of batteries. Then proper storage and transportation so that environmental impact is not there. So we have to design a proper transportation system similar to biomedical waste, but again it's not the responsibility of the ULB to design that transportation system. Maybe it can facilitate, but primarily batteries are the responsibility of the consumer. After consumption of the battery or use of the battery, it should be deposited to the dealer or manufacturer or importer, assembler, registered recycler or reconditioner or collection center. So these are some of the references you can use. To conclude, plastic waste management plan should be developed in conjunction with extended producer responsibilities, and special waste generated in urban areas should be kept separate from municipal waste streams for treatment and recycling in specialized facilities.